years now, founded by Jake Breckman, who's in the house. A few of us, some of our wonderful summer interns are here, so we're really excited to meet you guys and get to know you all a little bit better. Thank you all, especially who trekked through the L train meltdown that was happening. We really appreciate you doing that. Rabbithole Talks, as you guys know, is a monthly or bi-monthly kind of happy hour meetup where we bring a super interesting or innovative blockchain startup that is working on some particularly innovative crypto economics or solving a particularly interesting problem, in to just talk a little bit more about what they're working on. And today I'm really pleased to present Konstantin Richter of Blockdaemon. Blockdaemon is one of our portfolio companies, and we've loved working with them over the past few months. Blockdaemon is a multi-cloud node infrastructure and deployment platform that supports multiple public and private protocols, including Ethereum, Stellar, Quorum, and more recently they've been doing a ton of work with Algorand, so definitely talk to him about that. Konstantin has been an advisor to many blockchain projects previously, prior to launching Blockdaemon in 2017. Previously was an entrepreneur in the SaaS B2B space, running and exiting many different companies. There's a long list. And yeah, it's been a pleasure to work with these past few months. So really excited to have Konstantin here to speak with us today. And yeah, I'll let him go.
Thank you. This introduction. What half Lean said. I don't know if you guys have trouble seeing me or hearing me. I'll stand. Yeah, thanks so much. I'm Konstantin. I work with Blockdaemon, where I kind of used to use the term nodes as a service provider. The company is nearing 2 years in age. I've been an avid fan of blockchain networks. Mostly really what excited me, coming from the sort of more SaaS B2B place where you try to build data models that avoided technical debt and turned them into marketplaces. I got excited about blockchain because I felt like there's this sort of inherent sort of ability to create network effect that can be really powerful to go for network adoption, right? So I got really excited about that back in the day. And then Blockdaemon was started really to be a sort of blend of like a Heroku New Relic type product suite and developer tooling middleware platform. And here we are. And what I'm going to do today is share a little bit of my experience. By no means are we experts, but we've dabbled sort of around with quite a few different protocols on lots of different ways and configurations. And so I want to talk a little bit about how we go about it, what we like, what we don't like, and kind of sort of the makeup and topology of some of those networks. So I'm going to try not to get too technical because I'm also not very good at it. But other than that, and then ideally we have some time for questions. So this is us. Just a sort of pretty simple introduction. We in this sort of popular spiel these days. Really, auto-scaling nodes for a lot of different providers across a lot of different infrastructures, and then build economical models around it. One of the key things that we've always felt is important is that we don't offer staking as a service in terms of, we don't really take a share of rewards. We're a very simple credit card monthly payments provider. And so fuels us. You can go to our website. Most of these are live. I think live on the website we have like 13 protocols. We support around 20, 21. Some of those are fairly special. We have our own little data center where we can like plug and play, and some of those nodes we run on there. And so we support quite a few different projects. And then one of the other big things I think we've spent quite a bit of time on now is figure out how to offer SLAs and how to be SOC compliant and go for ISO standards in a place where everything, like it's actually really complicated because things change so quickly. So it's very hard to kind of define processes that adhere to kind of those normal platform standards. And so we're also spending some time going through that. So one of the ways we go about thinking about networks, and one of the complexities we found is when you run a lot of different nodes across a lot of different infrastructures, was how do we figure out how to monitor them? And so we kind of had to learn that the hard way when we last year launched like the Volcoin network, for example, where like monitoring VMs is relatively standard. Like there's a lot of tooling you can use in order to do that in the cloud space, but blockchains have very particular properties, and so it took us a while to actually figure out how to go about doing that. And I'm going to talk a little bit about that. But the key part for us is that we really, deploying things is very easy. Like there's a lot of tools that you can do. You can write little scripts that deploy a node. The configuration takes a little bit of time, but the real art is to actually keep a node live connected at an economical size and performing on the network, right? And so how do you automate that? And how do you do that well? And so that's sort of how we've built our architecture. On the right, you can see, kind of one of our, it's a screenshot, I'm guessing, of one of the protocols we support. You can see a number of nodes. We have what we call the decentralization score, which is a quasi-philosophical score, really, something we kind of made up. Decentralization is, of course, the big subject du jour for us. We started with wanting to be decentralized. We were the first hybrid cloud solution in the space. Really, what that means is that we initially were kind of trying to counter the world in which some projects end up having all the nodes on Amazon list or something, and then obviously decentralization has so many different layers. It starts with consensus mechanisms. It starts with where do you actually put down the physical infrastructure, and then you can actually play it further down to kind of if you use Docker, there's security concerns there. Even the Kubernetes, I think actually just today or 2 days ago, they had a huge patch on like a security issue. And so this sort of mixture of cloud tooling and open source methodology makes decentralization and like let's say perfect trustless networks quasi impossible, right? And so we need to define combinations of legal and technical ways to kind of zone in on a sort of relatively low fault rate. The other thing that we've thought, I'm going to share that because I've always thought it's funny. So I always thought decentralization is super important. Like it's one of the main things why I love blockchain, and we really led with that a lot. And the reality is very few people care. People care about decentralization in projects they're not involved with, right? So people like to throw that out there when there's a project they're not intimately involved in. It's like that's not a real project. They're not decentralized. And so I kind of find that very interesting because the way we structure most of the economical models, even in staking networks these days, they actually always go towards concentration of network and compute power. We haven't really figured out how to do that well. And the reality is there's a lot of talk about like decentralization and those type of things, but actually very few people are prepared to pay for it. A good example is, and it's one of my favorite clients, so maybe I use a competitor, Ripple. Ripple is a good example of a company, so they run a certain amount of heavy nodes. There used to be very few nodes for a long time. A lot of people don't think of Ripple as really a crypto project. But what's interesting is there's also no incentive for anyone on the network to physically run a node, nor will Ripple pay anyone to do it. And so there's all this talk about like we're going to increase our validator networks, and we're going to, and you're kind of like, how is this going to happen? You expect people to pay, a fortune because these machines with a full archive tend to get very, very large. And so it's kind of interesting, and you can go through pretty much every network and you'll find one degree of a problem there. Either it's in the consensus mechanism or it's actually in the way they reward node running. So just out of, just that, like the whole decentralization score for me was like, I thought, oh man, this is the perfect marketing ploy. I'm going to have a percentage number, and that's going to really shame networks, and then they're going to buy more nodes, and everybody was like, and so, but they like using it, if at all, to kind of point to a competitor and be like, oh yeah, look at these guys. So that was always funny. But so a couple of things as well. I think one of the things we've learned that we've spent way too much time on very early on is we always wanted to orchestrate complete networks. So we thought a lot about load balance, geo-dispersion, building stuff with like sort of trendy stack components like Kubernetes and Terraform and stuff. And so under the belief that there is somewhere a market where it makes sense to actually orchestrate complete networks, not just individual nodes. And so we started our product from a network perspective, and now we actually zone in a lot more on the individual node. So that's also been sort of kind of interesting. There's a lot less demand for people to actually help orchestrate networks. People really care about, the lowest common denominator of those networks, which is the individual node, which might have an impact if it doesn't perform well on the network and on them personally, specifically with slashing and other instances. So here we are. So we thought a lot about like what are kind of sort of good like node level things to kind of look at. And so there's and here are a couple, right? So we use a sort of whole influx of CloudFormation tooling. There's a lot of great stuff available to kind of do this stuff. You kind of have to hack it a little bit together, but there's block height, peer count, uptime, number of transactions sent to a node, transactions pending in the ticket pool, queue transaction, additional protocol-specific metrics, like the list goes on and on and on. There isn't really a comprehensive one. It looks a little different per blockchain protocol. It's at least my experience. Other people might have a different experience with it, but for us it's been very, very iterative. So we tend to integrate and build components in our monitoring, and then something happens that we haven't thought about, and then we start continuously add to it. And so that's been interesting for us to kind of see I would say the whole monitoring component of blockchains, not just on actual health of a node, and then the network level is still very archaic. And there's a lot to be done to get that to the level that we're used to. And there's been interesting efforts. So in the cloud space, like for example, I think companies like Splunk, for example, actually launching really interesting things, but they all come at really, really heavy price points, right? So those are really dense sort of heavy solutions. So for us, like the big bit here was we always wanted to ensure uptime and connectivity. It's all pretty standard stuff, like looks like a complicated diagram. It's pretty New Relic-y. There's nothing magical on there really. The big part for us is that each individual blockchain component gets auto-scaled, right? So we keep them all separate. We actually then within the node level keep them separate. You try to keep latency to a minimum. We never fix nodes. We kill them and roll them forward. So another thing we've learned is it's really a waste of time to kind of sort of, at least for us, to go back and constantly rejiggle nodes. What we tend to do is we tend to rewrite package managers, and we just deploy snapshot it and deploy new nodes. So we kind of constantly kill nodes. Like, so we have a pretty high cycle through of dead nodes lying around. The hard part for us is always configuration, and then keeping the configuration up to date with the demands of the network. And so just kind of so those were the things that we found interesting and we spent quite a bit of time on. I talked about the sort of decentralization score. The sort of main metrics, just also to go in there, like the way we've defined it. The whole idea for that score was that a customer that for us on this level is a protocol can actually define network parameters like we don't want more than 10% of the total nodes to be on any individual data center. We need to have X, however you want to measure latency. We don't want 50% of nodes to be in region X or something like that, and then dynamically actually change the way individual node participants can select infrastructure and actually make that a dynamic sort of tool that automatically balances this out all the time. So that was always the initial starting point. We've developed this algorithm. The big thing where we hit for us, where we hit a lot of walls relatively early on working with enterprises and stuff, that we've learned that when you get to juicy use cases, people really want to own the node and actually have them on-prem, right? So initially we had this all pre-configured. We have like 100 data centers pre-configured, and it's all like one sexy little thing. And then once you actually get to the detail and real stuff happens, people really want to make sure that they can actually control the node, and even we don't have access to it. And there's degrees of it. Like some people don't understand that at all. Like, so we have large customers who are like, oh, I don't know, I don't care. Like, it seems fine. We signed a legal contract for a U.S. entity. Some people are comfortable with this. others aren't. And so we had to also then figure out how do we connect nodes that we haven't physically launched to this dashboard to actually monitor and manage them. Which is sort of for us now the exciting part, and I'm going to talk a little bit about that. But and so here's some of the categories. So like the right verifiable independent node owners, number of nodes on the network, distinct cloud data centers, distinct geo-availability zones. Nodes run outside of our parameter, like, we try to sort of kind of make it kind of sort of a little, complete sort of network count that ideally the network can survive with. The test cases are always, kind of what happens when I step in front of a bus, right? So when me, meaning everyone who works at Blockdaemon, like a rocket goes off in our building, like, what happens to your nodes, right? So is your network still standing? And the answer is yes, because we don't run the nodes in our building. I always like to describe nodes sometimes, like in the early days, I always used to tell people it's a little bit like an old lawnmower. You kind of like jiggle it up and it's like, and then they kind of constantly blow off and go sideways. And it feels a little bit like it, but it's important to really think about what business continuity actually looks like for these networks also on a complete level. And actually very, very few networks actually physically do it. I think, again, Stella is a good example of actually a network that did that, at least to the extent that they said when something goes off, we shut everything down, which actually is pretty advanced from a blockchain network level. And they had actually an outage a couple of weeks ago, and that's exactly what happened. And actually kind of, quite a few people were pretty upset about it, but actually the system actually worked, which was the consensus couldn't be reached. And instead of, kind of sort of somehow forking the system or moving onwards, the system just came to a halt. And so that's one simple way to kind of deal with some of this. And so, now we're working on, we do a lot of predictive launch of registered resources. We work with a startup called Manifold. They do, kind of really interesting cloud orchestration stuff. It's probably, the reality is we kind of like doing it. I don't really know if anyone cares because it gets pretty sophisticated. And again, most networks deal with this when things don't work. Kind of the actual pain threshold for networks, I think, and protocols to really engage in this stuff is if it actually really actively affects their probably financial ability is actually the truth. And so we'll see how that moves and comes along. A couple of things also that we always get asked. So initially it was always do you have access to machines? What happens with data at rest, data in transit, end-to-end encryption? How do we handle SSH, certifications, all those type of things, right? So those are then now all the sort of, and again, it's kind of super interesting who actually asks the questions, out of our customer pool, the people who actually care about this stuff, and then the people who really don't. But there's obviously, this is a continuous evolution of how do we actually physically evolve our platform to actually provide a node management experience that hits continuous use cases. We're also currently doing some ISO stuff. I kind of want to talk about it briefly just because I've dealt with this stuff on the SaaS world quite a lot. I don't know how other people think about it. I feel we get asked a lot from large enterprises because if you deal with a large Fortune 500, a lot of times they have purchase departments and they have sort of hard-coded requirements that they have when you actually physically want to sell them certain software products. And they get a little, very often this is a requirement. I kind of feel I don't know if any blockchain company, you can have it in an individual data center. I don't know how you deal with it in an iterative, agile environment where things need to get touched a lot, right? So it's one of the big issues, I think, at this point in time is we're still really, really far away from my perspective to provide sort of this type of software standard and security for any of these networks, which I think is probably reflected in the sad reality of live enterprise blockchain projects in those cases, right? So there's a correlation there as well. The other thing that I've mentioned for us is we're kind of really focused on monitoring, and so for us it's really package management systems. So we try to move away from there's a real commoditization going on with actually physically deploying nodes and running them. A lot of people are doing it these days, and it's a little bit of a which is great that there's tooling becoming available that makes this easier. And for us now, the big challenge is actually, again, how do you actually continue to monitor and track performance of complete networks? So we're kind of slowly going back to where we really like to be, which is to actually look at network orchestration and do it in a way where we actually physically have nothing to do with the data center or the physical node, right? So that's sort of something we spend a lot of time on, and we launched our first package manager product in the middle of July with a couple of projects, and you know, we're going to see how that plays out. For us, that's been super interesting because it sits alongside all the existing solutions, but it gives people also a degree of you know, certification, for example, something we could offer, particular performance indicators, etc. And so that's interesting of us. And then a couple of random brand names, if you're interested, like I think most folks are familiar with most of those if you work in the space. You know, we kind of sort of, there's a lot of different data flowing around, and the question is, how do you kind of capture it, and then how do you actually physically package it in a dashboard that somebody could find useful and then ideally act on, right? So there's quite a bit of stuff there. This is a really boring slide. Horrible graphic. And then we have, like, you know, data feeds. Yeah, I kind of find the whole data stuff also really fascinating, and I don't know enough about it, like in terms of like what other folks are doing. I know there's a lot of data projects, but on the physical network side and things, like there's just so much information, and it's really interesting on like how to actually physically harness it for users, because there's different sort of hierarchies of information, right? So you have like node hierarchies, and then you go up to like, you know, hubs and clusters, and then you go up to actually the physical overall protocol. So we spent a lot of time on like, you know, what are the sort of data access and premium feeds of like things that we can actually extrapolate out of those, and how do we expose them in a UI that makes sense. So a lot of work to be done from my perspective. So a couple of things. So issues and gaps in tooling. Again, my kind of limited understanding is that the way I thought I can go about stuff by using CloudFormation tooling was partly true. There are certain components that are very easy, but in specifically auto-scaling and sizing distributed ledger technologies, there's still a lot of issues. Most of the tools in the CloudFormation space are built for web applications, and web applications, you know, have different properties than you know, when you deal with physical blockchain, because they normally scale by just adding more machine power to something, right? And if you think about what we wanted to do initially, which is orchestrate decentralized networks, it's much more around horizontally sort of scaling out networks, and that presents different challenges to those systems. The other thing is that nodes can take a really long time to sync. And it's always fascinating to me, like and it depends on types of nodes. Nodes also, when we talk about nodes, like there's so many different degrees of nodes. They're a little bit like remnants in terms of, you know, like kind of each blockchain is very different from the other, and then there's a lot of different types of nodes. You know, a node is a random term. There's nodes that can carry a full archive, and they can be enormous. And there's nodes in some of the projects we've done that can take a month to sync a node. And so that's not uncommon. Nodes can hold the archive of every physical transaction, of actually every code commit that ever was put on the blockchain. And so these things can get enormous. And so when you have some of the older projects, they actually pay random companies a lot of money to maintain particular nodes that have, you know, that are old and actually have a copy of all the different transactions and are seen to be mostly correct. There's also, and I don't know how that happens, but like there's also a lot of faults in individual nodes when you actually physically go through the archives. Like no two nodes ever really look alike, unless you copy them, and then, you know, you're kind of cheating the system a little bit too. So software is never as linear as it looks. Adding nodes to a live environment for us also is kind of interesting because it can impact the overall network performance. And I don't really know, I don't have an answer for that yet. The blockchains are usually conceptualized by enthusiasts who think a lot about the security on the protocol, but then very little about the security of the physical overall blockchain configured on clouds. Key management is still something where I haven't seen a lot of great software that integrates easily. It's still, you know, so key components of what make blockchain interesting are still very manually handled in spreadsheets and sent around, and that's definitely something that needs a little bit more work. And then I talked about the network level, IP addresses, a little bit of an issue. I think I leave it at that. So, so if you're interested, we always recommend people also to try stuff out. I don't know, who you guys really are and what your experience grade is. I always like to point out that I think it's great if you are interested in the space to actually support the networks you care about. I always like to point people towards Bitcoin specifically, just because it's one of the networks. It was our first love. It was the first protocol we deployed. I think, and I don't know, for a long time at least, we were the first and only sort of simple deployment tool for Bitcoin. You can go to our website now. You can click 2-3 button. You close the Bitcoin node. Question is, why would you do it? It's not a mining node, and so we really want to do it because the Bitcoin network, the more nodes are on it, the more stable the network becomes. We've also just actually this week launched this sort of enterprise Lightning integration on it, where we actually run, you can actually run the full Bitcoin node. We add LND components to it, and then have an RTL dashboard, and so you can actually have a fully monitored and managed sort of node that can actually carry Lightning channels as well. So I think the other thing I'd like to point out, there's I think there's a couple of dozen really interesting infrastructure projects that deal with components of this in interesting ways, and so I by no means have a comprehensive overview of what that looks like, but there are certain projects that deal with some of this really well. Personally, I really like Polkadot, for example. I think there's really interesting components of how they've even thought about the whole sort of network structure, as well as how they actually work with individual blockchains. I think Cosmos is a great project as well. I think there's a lot of others. There's a lot of work done on SDKs specifically and how to actually make it easy to interact with a lot of those. I think there's some interesting projects there that are worth to look at. I think the future of all of this is going to be interesting. I was talking to Lauren about this once. I kind of never know, are we going to have a business in 3-4 years or not? I can go both ways. I'm a very bullish position of we're going to be the APIs of the future, and there's and then I can go the opposite way. And so it's kind of interesting. It's definitely super early. It's shifting and changing all the time. But luckily enough, again, there's great tools, great things happening in the open source community, and we have a lot of precedents that we can use when we orchestrate these particular networks. Go to our site. You can deploy Bitcoin for free, I think, for the first 30 days. Try that out. It'll you do us a favor, do the Bitcoin network a favor. You can also check out a bunch of other protocols, right? So you can just kind of have a look. And not really for the faint-hearted. If you're not an engineer or super focused on it, I think Bitcoin probably suffices for now. So that's it. Thank you, guys.
Take some
Sure.
questions.
Yeah. You have questions? Definitely there.
Do you foresee nodes growing in size and complexity, or decreasing in size and complexity? More nodes on a given network and smaller, bite-sized requirements for the machines running?
I mean, I can tell you what I would like to see, but I think.
What have you seen in the past 6 months to a year?
Well, it really depends on the type of node. You know what I mean? It's a little bit, when people talk about nodes, it's like we're talking about cars.
Yeah.
You know what I mean? What about cars? Well, there's a Porsche and then there's a minivan, and they're just conceptually very different. And so I think the way I see a lot of this evolve is in hierarchies of nodes, and I think there's going to be nodes that are going to be really strong and heavy, and then there's nodes that are going to be maybe even just exist for a nanosecond down the line, that exist for maybe one data point, and then they hash. You could snapshot and hash down into a hierarchy of nodes, for example. I think that's kind of one way I would structure a data architecture that seems to be sort of taking the sort of hash component of blockchains into consideration without having to have each node be super massive, because obviously that's not.
So you're seeing more of a differentiation of full app nodes to different ones?
I think so. Yeah.
So you mentioned key management. Do you guys find that you need to roll special software to do this correctly, or do you find that you're interfacing with network developers to try to get new features so this becomes easier to kind of professionalized environment?
Yeah, great question. I mean, so there's a business owner answer in which I always try to refer to the protocol owner for security, right? So like there's this sort of point where I'm like, it's a lot easier for me to, when we launch a protocol where we handle keys and there's value connected to them, I adhere to the security protocol of that network because I don't want to fuck it up and then be the guy who's liable, right? So I'd rather than go back and say, no, this is Polkadot. Like, don't come talk to me, that's how they set up their key management. I do want to say that we've spoken with a couple of companies and we thought about like building a particular product for it. Like I do think there's total room for it, like a sort of software product that actually handles the transfer of keys and activations of keys and signing transactions in a way that nobody can fully touch it. Because there is always a weird sort of touch point that I found when it comes to activating these keys. Like I haven't seen a lot of great stuff there. So for me, that would be actually one of the gaps. I'm kind of sort of like, oh, that's an exciting potential software product there. And I know there's companies thinking about it and working on it.
Wait, can I have a follow-up?
Yeah, sure.
Do you find that networks are dramatically different, that it's hard to generalize software to handle?
I mean, again, it's like cars, right? Like, so most of them have 4 tires, but then the engines can be really different. And so I feel like they all speak very different languages. A lot of them are also very unprofessional. Like it really depends on the history and where they came from. I think and so I mean we've launched some mainnets over the last years. Like I mean it's on any standard of professional cloud management, it was atrocious. And I would say that goes for 85 to 90% of the networks that are out there. I think there's very little time spent on proper security, for example. And I think, yeah, so I do think it's vastly different. But and then a lot of it is actually best practices and who kind of sort of runs these projects and how serious do they take it, you know? Like it's also not necessarily rocket science, like there's ways to kind of go about it, but it's a lot of it is process. And a lot of people also don't have the experience necessarily to maybe do it, you know?